Okay. Okay. So rest and motion are the relative terms. I'm going to take two frames here. This is frame 1 and this is frame 2. So I'm always going to compare two frames to check whether the object is in motion or is it at rest. Okay, so now let us see how these states of motion and rest are related. For example, rest and motion are relative terms. They are not absolute. A body can be at rest or in motion with respect to the reference frame. Sometimes you might have wondered, sitting in a train, okay, and if another train is passing by, you feel that your train is moving. So this kind of confusion, it happens in your daily life. So that is how first we'll define what is motion, what is rest. So I am going to compare. Imagine now you are sitting in classroom, you are all at rest, okay, you are all at rest. But now if I go in space and if I see you, you know, the earth is rotating, so you are moving with the earth, I feel you are at motion. So there is no frame of reference which is perfectly at rest. A man is moving, a man in a moving train is at rest with respect to a co-passenger, but he is in motion with respect to a man outside the train. Imagine you are sitting in a train. Inside the train, you have a passenger, co-passenger. You both are at rest. But if there is another train passing, the train in which you are there, you feel that other passengers in the other train, they are in motion. Okay, so these are the two things that you have to keep in mind. Next, let us have a small question and answer. A particle is an object having negligible. Try to answer it. Answer is dimensions. Next, rigid body is a combination of particles, and when external forces applied, there will be no change in its magnitude, dimensions, magnitude and direction alone. Okay, answer is dimensions. Next, rest and motion are dash terms: absolute, not absolute, relative, both B and C. Answer is both B and C. It's not absolute and it's relative. Next, types of motion. We have basically three types of motion. Let us take an example of a crawling ants here. So here you can see the ants are moving in a straight line. Now let us take a top view. If I look at this ant from the top, they look like they are moving in a straight line. So what type of motion is this? So this motion is a straight line motion. Now let us take an example of cockroach moving on a floor. This is cockroach and it is moving on a floor. So now what type of motion is it? So this kind of motion is called as motion in plane. Okay, motion in plane. We'll see this in the next chapter, motion in plane. Flying honeybee. So here you have honeybee which is flying. We have seen the motion in straight line, motion in plane. Now we have left with one more motion. Can you tell me what is this? What kind of motion is this? Yes, this is motion in space. Okay, this is motion in space. Next, types of motion. We have seen motion in one dimension. So one dimension motion is called as motion in straight line. Motion in two dimension, we have seen an example of cockroach, that is called as motion in plane. And then we have motion in three dimension, we have seen an example of honeybee, so this is called as motion in space. Now try to answer this question. How many types of motions are there? 2, 4, 3, 1. Answer is 3. Motion in one dimension is also called motion in space, motion in a plane, motion in a straight line, motion under gravity. Answer is motion in straight line. Next, rectilinear motion. So first let us try to understand what's the meaning of rectilinear. Recti plus linear. What is the meaning of recti? Recti means straight. And what is the meaning of linear? Linear means line. So a motion in a straight line is also known as rectilinear motion. Motion along a straight line here is an example like car on a road. Okay, so a car moving on a road is a example of a rectilinear motion. Rectilinear motion need not be one dimensional necessarily. It's not compulsory. Rectilinear motion can be a straight line in any direction. It can be next direction, y direction, positive y direction, negative y direction, positive x and negative x. But it is always possible that rectilinear motion be treated as one dimension motion only. Look at this now. Here you have an x-axis and y-axis, plus x and minus x, plus y and minus y. Okay, and if I tilt this, imagine if I tilt this axis up to certain angle, and now I take an readings now a car moving in a straight line. Okay, the rotation of the coordinated system does not change the rectilinear motion of the car. If I rotate the axis, it's not going to change the rectilinear motion. That means it is always moving in a straight line. The car direction will be in the straight line. Okay, next, scalar quantity. What is the meaning of scalar quantity? A quantity with magnitude alone but has no direction is called a scalar quantity. For example, path length or speed. Now, here in physics, we have something called a scalar quantity and vector quantity. Now, suppose if I ask you, at what speed you ride your bike? Just a minute. Okay, so if I ask you at what speed if you ride your bike, you are going to tell in kilometer per hour or meter per second, something like that. You are not going to tell 60 kilometer per hour in each direction. You are not going to mention the direction. So those kind of examples are called as scalar quantity. Just a minute. Okay, next let us try to understand vector quantity. Quantity with both magnitude and direction, they are called as vector quantity. For example, displacement, velocity, etc. Now, path length and displacement. This is a basic concept that you have to understand, because without understanding its total distance traveled by an object from initial to final position. Next, you have displacement, shortest distance between the initial and the final position. That is called as the displacement. Next, you have, imagine this is a home, okay, and a boy is now going to travel from his home to college, and now after his college he will try going to imagine to have a snacks in McDonald's. Okay, so imagine this boy is going to travel from home to college, and then from college to he goes back to McDonald's and again goes back to home. Okay, so now what is the path length traveled? The distance from home to college. Okay, look at the formula here in the box here. Path length traveled is given as the distance traveled from the home to college and then from college to McDonald in this case. What is the meaning of displacement? Displacement means the shortest distance. Now if just check the initial position home and the final position, that is McDonald. So that is called as a displacement, shortest distance. Next, so what is the difference between path length and displacement? So look at this now. Initial position is home and the final position is McDonald here. A boy is traveling from his home to the final position McDonald. So this is called as the path length. Okay, so path length is from home to McDonald. Okay, next, the what is the meaning of displacement? Okay, displacement is from home to McDonald once again. So in this case, what is happening? The path length, now in your exam, the question can be asked, is it possible the path length and the displacement be the same? Can it be equal? The answer is yes. The path length traveled and the displacement may be sometime be equal, as we have seen in this case. Okay, now let us move on the next case here. Path length, can it be equal to 0 or cannot be equal to 0? But what about displacement? Look at this. We have a home and we have here McDonald's. A boy is going to travel. Okay, so boy traveled from his home to McDonald's and again going back from McDonald's to his home. So here path length is L plus L. So path length cannot be 0. Okay, path length cannot be 0. But what about the displacement? Look at this. A boy is traveling from his home and again going back to his home. So the minimum distance is 0 here. Displacement will be 0. So in this case, we have proved that the path length is always greater than 0 while the displacement can be equal to 0. Next, the magnitude of displacement may or may not be equal to path length traveled by an object. The magnitude of the displacement for a complete motion may be 0, but the corresponding path length is not 0. Fine. So whatever I have explained, they have given you in sentences. Don't get confused. Now let us try to answer some questions. Correct statement among the following is, which among the following is a correct statement? Try to answer it. When displacement is 0, distance traveled is not 0. Second option, when displacement is 0, distance traveled is also 0. Third option, when distance is 0, displacement is not 0. Fourth option, distance traveled and displacement are always equal. Try answering this. The answer is option A. Option 1. Next. The numerical ratio of displacement to distance is. What is the ratio of displacement to distance? Always less than 1, always greater than 1, always equal to 1, maybe less than 1 or equal to 1. Answer is 4. Maybe less than 1 or equal to 1, because we have seen the distance cannot be equal to 0. Next, the total distance traveled by an object from initial to final position is known as this. It's a definition. The total distance traveled by an object from initial to the final position. What it is? Is it a speed, the path length, is it the displacement, or is it the distance? The total distance traveled by an object from initial to final position. The answer is path length. Option B. Next, what is the meaning of uniform motion? What is uniform motion? If an object is moving along a straight line, covers equal distance at equal interval of time, however small the time interval may be, it is said to be uniform motion along a straight line. Okay, so look at this now. Here I have an example. A school bus is traveling 10 meters every second. So the first instance, you have school bus is traveling 10 meter in the first 1 second. Then again the other 1 second it is traveling 10 meter. Again 10 meter in the next 1 second. So the bus is moving at a uniform motion. Next, speed, the rate at which an object covers a distance. So it's a scalar quantity. The formula is speed is equal to path length by time taken. You can take down this formula in your notebook. Very important. So from here onwards, your formulas and concept oriented questions will be asked in your exam. So take it down. Speed is equal to path length by time taken. What is velocity? Velocity, rate at which an object changes its position in a given direction. So we have seen speed is a scalar quantity, but velocity is a vector quantity. So vector quantity here is displacement by time taken. Very important. The difference between the formula of speed and velocity is the distance traveled and the displacement. So take down the formula for velocity also. Velocity is equal to displacement by time taken. Displacement by time taken. Okay. Next, let us try to see an example here. Now this is home and this is McDonald. A boy is traveling from his home to the final position, that is McDonald's, and again he's going back to his home. So during the total journey, let the distance be 2 kilometer and the time be 1 hour. Okay, so let us assume the total distance is 2 kilometer. So what is the path length? It is total 4, because he is going to travel back from McDonald to his home. So distance traveled is, the path length is, you can say, 4, and the displacement is 0. Now if you use this in formula, speed, you have written the formula path length by time taken, so 4 by 1. So 4 kilometer per hour is a speed and velocity is displacement by time taken. So 0 by 1, answer is 0. So velocity can be considered as 0. Now let us try to answer next question. Speed is a dash quantity, scalar, vector, neither scalar nor vector, both scalar and vector. What is the answer? Speed is a scalar quantity. Next, velocity is a dash quantity, scalar, vector, neither scalar or vector, both scalar and vector. Answer is vector. Velocity is a vector quantity. Fine. I hope you have understood the basics. Now let us try to understand another important topics here. Now these topics will be little interesting, at the same time very important for your science perspective or your exams. So from right now you have to draw some graphs in your notebook. So be ready. Distance time graphs. Okay, we have distance time graph. So take it down. Slope of a distance time graph is equal to speed. You can just take it down in your notebook. Be ready. Quickly write it down in your notebook. Slope of a distance time graph is equal to speed. You know the formula of speed. Speed is equal to path length by the time taken. So imagine this is x-axis, this is y-axis, this is positive x-axis 1, 2, 3, 4 up to infinity. This is negative values of x-axis up to infinity, positive of y up to infinity, and negative of y-axis up to infinity. So here towards y I am going to measure distance. Okay, so towards y, try to understand the graph first. If you understand the graph, it is very easy for you to solve the questions or answer the questions in your exam. So on y axis I'll be taking distance, and on the x axis I'll be taking time. Okay, and on the x axis I'll be taking time. So now you can see a red light is blinking on the screen. It is originating from the origin 0, 0, and it is going straight. Okay, so it is going straight, the red line is going straight. So what does it mean now? So imagine I'm considering here the 4, a small angle I'm going to make here. Okay, look at this, a small angle I'm going to make here. So this angle is called as theta, and now this theta, equation of the straight line, y is equal to mx plus c. You have studied in your mathematics the standard equation of the straight line is a linear equation. Since we are watching particle in a straight line, the linear equation y is equal to mx plus c is the standard equation of a straight line. Okay, so now what is m? M is nothing but the slope of the line, that is speed. Look at this now. Y is equal to mx plus c. Very important, try to understand. Y is equal to mx plus c. After this description is over, you are going to write down this in your notebook. Y is equal to mx plus c is the standard equation of a straight line. Now let us try to understand what happens here. M is nothing but the slope. Y by x is equal to tan theta. Okay, so I can say m is equal to y by x. So what is y here? According to the graph, in y I have taken distance and in x I have taken time. So what is distance by time taken? It is a speed. It is a speed. Okay. So now m is equal to speed. Okay. Now you have to take some cases now here. Let us take this case now. Case number 1. Okay. Slow position time graph. Now what is velocity? What happens? Okay, now for example, a boy is traveling from home to McDonald and again from McDonald to home. So total distance traveled is 4. Okay, so I am here drawing a graph of a boy traveling from home to McDonald's and again going back from McDonald's to his home. So total distance is 4. Okay, and now, so this is the graph of the velocity. Okay, next, slope of position time graph, case 2. This is with the help of the angle. You can see I'm going to make an angle that is 180 minus theta 2. Okay, so the distance traveled and the time taken, that is the speed. And now here you have the velocity, another slope of the second line. So the total answer will be slope of the first plus slope of the second will be equal to 0. So velocity slope will be equal to 0. Okay, so now tan theta is equal to 1 and the slope of the second line will be in the negative. So answer is 0. Plus 1 minus 1 will be equal to 0. We have understood from this. Let us try to understand. Imagine this graph here, case number 3, position time graph. So here the black line which you can see on the screen, it is starting from the number 1 from the x-axis. That means for the first 1 hour there is no movement. Okay, so now look at this. The body is at rest for first hour because the line it is starting from the x-axis. It is not starting from the 0. Okay, x-axis का 0 से नहीं, x-axis के 0.1 से start हो रहा है. ठीक है. So uniform motion after that. So after the body starts from rest after 1 hour, look at this, the line is going straight. So at equal distance and equal time, so that is called as uniform motion. Okay, next we'll take another example. Look at this. Okay, look at this graph now. X-axis is time, y-axis is position or distance. You can see between 0 to 1. Okay, between 0 to 1 the motion is, okay, in a uniform motion. It's in a constant time and constant distance. But after 1 there is non-uniform motion. So after 1 what happens, the body is moving at different speed at different time taken. Okay, and towards the end there is rest. Now try to answer this question. The slope of velocity time curve at any instant of time gives the slope of velocity time curve. You have just seen velocity time curve, what it gives you. Yes, answer. When it comes to velocity, you should remember the formula. What is a velocity formula? Displacement by time taken. So here you have acceleration, because we will get to know from the help of the graph how it is going to move, at what speed is going to move, what acceleration is going to move. Next, the slope of position time graph gives us the speed, acceleration, retardation, velocity. The answer is velocity. Next, the slope of distance time graph gives the acceleration, retardation, velocity and speed. So what does it give you? Distance time graph gives you the speed. Next, in relation to velocity time graph, you get the curve can be a circle, the area under the curve and above the time axis between any two instants gives the average acceleration. The slope at any instant gives the rate of change of acceleration at that instant. The area under the curve and above the time axis gives the displacement. think over it and tell me. Yes, the answer is D. The area under the curve and above the time axis gives the displacement. Okay, we'll see this when we are doing the problems. So right now just remember it. Next, very important concept. What is average speed and the velocity? First we'll see what is average speed. Average speed is equal to measure of the total distance covered in a given time. The formula is total path divided by total time. So write down this formula in your notebook. Average speed is equal to total time by total path by total time. Next, average velocity, the measure of total displacement covered in a given time. So average velocity is total displacement by total time. Both this formula should be in your notebook. Average speed and average velocity, total displacement by total time taken. Next, let us have a graph now. So these graphs will be asked in your examination, including CDS, NDA, JE, or any examinations which you are trying. So try to draw this graph now quickly. So in x-axis you have time, and in y-axis you have the distance, position. So the position time graph for an object moving with a positive velocity is this. Then the option B is moving with the negative velocity. Okay, the graph, the line comes downwards. Next, here at rest, the third example is at, the object is at rest. Next, instantaneous speed and velocity. So we have successfully understood the concept of average speed and average velocity. Now we'll try to understand instantaneous speed and velocity. Instantaneous speed, measure of distance covered at every instant of time. Instantaneous velocity, you have measure of displacement covered at every instant of time. So what does it mean? Imagine you are traveling to Bangalore to Chennai, imagine, and if I you started at morning 6 o'clock and you reach by 12 o'clock, and if I ask you what was your speed at morning 10 a.m., so I am asking the speed at that instant, that time, 10 a.m. particularly I'm pinpointing it. So that kind of things are called as instantaneous. Okay, so instantaneous matlab, abhi for example Maggie. Okay, if you ask me how much time it takes to prepare a Maggie, it takes instantaneous, 2 minutes. Instantaneous coffee, instant Maggie. Okay, like that. So in how much time? Okay, so that particular time, in what time I want the speed or velocity, that is what I am going to check it. Okay, next you have instantaneous speed. Let delta x be the distance traveled in the time interval t. So definitely the time will be more, so I am taking t plus delta t here. Delta t means extra time here. The average speed in the interval will be delta x by delta t, the change in the speed. Next, as delta t, as the change in the time approaches 0, the distance traveled is also approaching 0, but the ratio has a finite limit. So what happens here, when I apply the concept of limit, so average velocity is equal to net displacement divided by total time taken. So instantaneous velocity, now here delta r is displacement in the time interval delta t. So you have instantaneous velocity of a particle at time t. So here I'm going to apply the limit function, and then I get this value. Fine. Next, moving ahead, average speed, you have taken down the formula. Average velocity, you have taken down the formulas, right? So how is average velocity different from the instantaneous velocity? The average velocity does not give any details of the motion of the particle. It gives only the result of the motion. The instantaneous velocity defines how fast the particle moves at a particular instant of time. So try to understand it. Now we'll try to solve some MCQs. So the average velocity does not give any details of the motion of the particle. It gives only the result of the motion. But the second case, instantaneous velocity, gives how fast the particle moves at a particular instant of time. I gave you an example that if you are traveling from Bangalore to Chennai, if I ask you at morning 10 a.m. what is your speed or what was your velocity, so that is called as instantaneous velocity. Okay, so linear motion, This formula is very important. Take it down. Average velocity. If they have given 3 speed and 3 time, then this is the formula. If a body travels with a velocity v1 for the first half and then velocity v2 for the second half, then the total average velocity will be this. Okay, so take down this formula. It will be helpful in your problem solving. Next, if a body covers first half of its journey with uniform velocity v1 and the second half of the journey with uniform velocity v2, then the average velocity is 2v1 v2 by v1 plus v2. So this formula is also important. Take it down. Most of the time in average related question they will ask you, if a man is traveling from his home to office at 30 km per hour and return back from his office to home at 50 km per hour, what is the average speed? So that time you are going to use this formula. Okay, next, if a body travels first one third of a distance with a speed v1 and the second one third of a distance with speed v3, then the formula is given as follows. So take down these formulas in your notebook quick. V is equal to 3 V1 V2 V3 divided by V1 plus V2 plus V2 by V3 plus V3 into V1. Next, let us try some questions here. The dash defines how fast the particle moves at a particular instant of time. Okay, so now here I think by this time you might have guessed what's the answer. So particular instant of time they are asking. So option A is average velocity, option B is average speed, option C is instantaneous velocity, and then option D is instantaneous speed. The answer is instantaneous velocity. Next, the dash does not give any details of the motion of the particle. It gives only the result of the motion. We have seen this definition just a few seconds back. We have seen this definition. I know you know the answer. Try to answer it now. Average speed, average velocity, instantaneous velocity, instantaneous speed. Answer is average velocity. Next, we'll try to see what is acceleration. What is the acceleration? Rate of change of velocity with respect to time is known as acceleration. So take down this formula. A is equal to change in velocity by change in time. It is a vector quantity, so direction will play a very important role. So here you have x-axis time and y-axis velocity. Slope is given by v by x, velocity by time. So this is acceleration with change in velocity by change in time. So these are the graphs which will be asked in your examination. So take down, try to draw this graph here. Position time graph for accelerated motion. So in the first case you have positive acceleration. In the second case you have negative acceleration. And in the third case you have zero acceleration. Okay, so they will sometimes ask you how the graph looks like of different acceleration, positive, negative, and zero. Now, acceleration zero. Let us try to understand when can an acceleration be zero. So look at this. If a car is at rest, I will say there is no acceleration, velocity is zero, hence acceleration is zero. Second, car in uniform motion or constant velocity. That means imagine here there is a car, okay, it is moving at a uniform motion. So what happens here? I will use a formula, that is Vf minus velocity final minus velocity initial divided by time. So here velocity in the final was equal to velocity in the initial, so both becomes equal, so that becomes 0, so 0 by t. So in these two cases, remember, in these two cases, when car is at rest or the car is at uniform motion, in these two cases velocity will be 0, that means acceleration becomes 0. Okay, just target on acceleration, so acceleration will become 0. Now let us try to draw a graph, velocity time graph for motions with constant acceleration. So motion in positive direction with positive acceleration. Okay, so this is how the graph looks like for the positive direction with positive acceleration. Next, Now here we have motion in positive direction with negative acceleration. Okay, so the acceleration is negative. You can see the black line slope downwards. Next, here you can see motion in negative direction with negative acceleration. Okay, so negative direction. Okay, negative direction with negative acceleration. Next, here you have positive direction but negative acceleration. Okay, so you have negative acceleration but the direction is positive. So these graphs are important. Next, between time 0 to t1 you can see it moves in positive x direction, and between time t1 and t2 it moves in the opposite direction. Okay, so now with the example when we do it on the board, that time it will be easy. So right now you just understand the graph looks like this also. And the logic here is, sometimes in exam they'll ask you question, can acceleration be negative? Yes, it can be negative. Can displacement be negative? Yes, it can be negative or zero. But what about distance? Distance cannot be negative. Okay, next, average and instantaneous acceleration. Average acceleration, change in velocity divided by time for a complete journey. Instantaneous acceleration, it is a rate of change of velocity at every instant of time. Now, the area under the velocity time curve is called as the displacement. Simple. Let us take a case here. Object with uniform velocity. Okay, so here you have a graph. On x-axis you have time, and in y-axis you have velocity, and you have a rectangle that is OABC. You can see a rectangle that is OABC. So area under the curve OABC. Okay, let us try to take the area under the curve OABC. So you all know the area of rectangle formula, that is length into breadth. So OA is length and OC is breadth. So what is OA value here? OA is equal to 4 and OB is equal to OC is equal to 3. So time into velocity. You know the formula for velocity. Velocity is nothing but displacement by time taken. So here you get the displacement. Okay, so displacement you get answer as 4 into 3, that is 12. So next, conclusion from the graphs. We have two types of graphs here. For one you get velocity and for other you get the acceleration, speed versus time. Now when we do the MCQs, that time these questions will be asked. Okay, distance versus time will give you velocity. Velocity versus times will give you acceleration. Or you can say position versus time. Okay, you will get confused, so keep it simple. Okay, next. And the area under the curve will give you displacement. So these 3 points should be in your notebook. Take it down. The first point here, the slope of PT, that is position and time, will give you velocity. The slope of VT, velocity and time, will give you acceleration. And area under the velocity time will give you the displacement. This will give you the displacement. Okay, fine. And one more thing you can add, that is slope of distance and time will give you speed. Okay, you can just say that slope of distance and time will give you speed. So let us try some questions now. Acceleration is the dash quantity, scalar, vector, neither scalar nor vector, both scalar and vector. The answer is vector quantity. Next, the distance covered by a moving body is directly proportional to the square of its time. The acceleration of the body is increasing, decreasing, zero, constant. So look at this. The distance covered by a moving object is directly proportional to the square of its time. So as the time is increasing, twice it is increasing, the distance is also increasing. So what happens? The acceleration of the body is constant. Okay, that means it is at uniform acceleration. Next, kinematic equation for uniformly accelerated motion. Okay, very important. Now here we have three kinematic equation. So take down this kinematic equation for your problem solving. Draw this graph in your notebook quickly. Draw this graph as it is and try to name O, A, D, C, B, everything. Try to draw it. Okay, after drawing this, let us consider the terms now. We have displacement, I'm denoting it with x. We have time taken, denoting it with t. Initial velocity is v naught and final velocity is v. Some of the textbooks, they will take initial velocity is u also, so be careful. Here I am taking v naught, that is your initial velocity, and final velocity is v. Okay, final is v, just remember this. Acceleration, I'm taking it as a. And three kinematic equation, I'm going to derive it by different methods. Okay, so look at this now. The three kinematic equation for uniformly accelerated motions are v is equal to v naught plus at. Some of the textbooks will mention v is equal to u plus at. Displacement, x is equal to v naught t plus half at square. Some of the textbooks will mention s is equal to ut plus half at square. Okay, you can also take it down as s is equal to ut plus half at square. So displacement is taken as s. Final velocity, v square is equal to v naught square plus 2ax. Some of the textbooks will mention v square is equal to u square plus 2as. Next, let us try to understand how I am going to get this answer of v is equal to v naught plus at or v is equal to u plus at. So look at this. This is the graph that you have drawn. If you haven't drawn, just try to do it faster. And just look at the derivation here now. What happens here? We know the formula for acceleration, dv by dt, correct? That is change in velocity by change in time, correct? So look at this now. Acceleration, final velocity minus initial velocity by time taken, that is equation number 1. Okay, now here what happens, I'm just going to cross multiply. At is equal to v minus v naught, and finally I get the first equation. So write down this equation derivation in your notebook quickly. Okay, have you written it? We'll move on with the next equation now. Here I have to prove x is equal to v naught t plus half at square, or s is equal to ut plus half at square. So I'm going to take this graph here. So OA is equal to BD is equal to T. Okay, so now look at this. OA on the x-axis, I'm considering it is time, and OADB is a rectangle. So BD is also equal to T. Okay, next OB is nothing but V naught, that is the initial velocity OB. So now you have CD is equal to BF and OF minus OB. I'm just going to subtract it. Okay, you just see F and O. Okay, point F and O. I just want CD. So for CD, I will just minus B minus V naught. Okay, so I substitute here. I know the formula for acceleration, V minus V naught by T. And I also know V minus V naught is equal to AT. Okay, so acceleration, you have done it in the last equation derivation. So I'm going to show you how to substitute and get the answer now here. Okay, so displacement is nothing but the area OACB. Okay, OACB. So now the complete area you have to add. So the area of rectangle plus area of triangle. What is the area of rectangle formula? Length into breadth. And what is area of right angle triangle? Half into base into height. Okay, so I know OA is equal to T. Okay, using this formula, when I substitute, you get the answer. Okay, so this is your answer, that is s is equal to ut plus half at square. So this is the second equation of kinematic equation of motion which I have derived it. So try to take it down in your notebook. Okay, next we'll move on with the third equation. Let us derive the third equation. V square is equal to u square plus 2ax. Okay, some of the textbook they will mention v naught as u, so you have to take it as u square. The first kinematic equation, you know, v is equal to v naught plus at, so t is equal to v minus v naught by a. And from second equation, you know, x is equal to v naught t plus half at square. Okay, so now I take x common, I substitute the value of t in the second equation, in the second kinematic equation, and I'm going to solve this. So try to copy it down quickly. Okay, I hope you have done it. Next, so when I solve this opening the bracket, finally I get the answer. Yes, that is v square is equal to v naught square plus 2ax. So we have successfully derived the three equations in a simple substitution method. We have another method of deriving this, that is with the help of the integration, that I'll be telling you in a short while. So try to take it down. Just take down the last answer. You can solve it at home and you can let me know what is the derivation here. Now let us try its MCQs here. Kinematic equations are applied for a uniformly dash motion, circular motion, retorted motion, decelerated motion, accelerated motion. Answer is accelerated motion. Okay, so whatever three equations we have seen now, the same three equations we are going to do with the help of calculus method. Calculus matlab differentiation, integration. But here I am going to use a method of differentiation. Most of you are in like 11th or first view, so you may not understand, so I'll just run over it. I'll just show you how it is. If you have doubt, you can come and personally ask me. I will tell you in your notebook. Okay, look at this now. I'll just quickly run over this slides now. Derivation of equation of motion using calculus method. Okay, so let us assume there is an object moving in a straight line, and the initial velocity u, that is equal to 0, and the time interval will be t. In the end it is 1. Okay, so velocity time relation, acceleration is change in velocity by time, so I take a is equal to dv by dt. Now integrating on both sides. So in 12th standard you are going to study a chapter called as integration. Okay, definite integration. So you have initial velocity and final velocity. I have taken the initial velocity as 0. Okay, that time taken is 0 and the final is t. So when I integrate this, I get this as v is equal to u plus at. So this is with the help of calculus method integration. I get the first equation. Then we have the vector form. Then we have the distance time relation. Okay, the displacement velocity is given by displacement by the time taken. Okay, so when you integrate on both sides, you get like this. So s is equal to ut plus half at square. So with the help of integration, we got the second equation also. S is equal to ut plus half at square. And third, rate of change of displacement. Okay, so here you have the third equation. Again integrating, you get v square is equal v square minus a square is equal to 2as. That's it. So this is how you are going to use the calculus. Now the 11th standard students, those who don't have the basics of integration, you may not understand this, you can come to me personally, I'll teach you. Okay, next. So we have done the chapter of a very hectic chapter of this one, like graphs. So now let us try to do a last. We have done with the graphs here. Okay. We'll do a freely falling body. So here you have motion in straight line, motion under gravity for a freely falling body. What happens if a object is falling from the space, or what happens when you throw something from the earth to the space? Okay, motion. So body dropped vertically downwards, that is freely falling body. An object is released under the influence of gravity, it is said to be a free fall. For example, here you have distance y, the initial velocity I'm taking it as 0, and down the final velocity is v. So I'm going to throw this apple. So this apple is on the space, I'm going to throw it down. See, look at this, now it is coming down, correct? So initially the velocity is 0, so I take it v naught is equal to 0, and finally when the apple comes down, the final velocity I'm taking it as v. Okay, so now here acceleration will be equal to g. Look at this in the screen I have given here. Acceleration a is equal to g, and I'm taking it as plus g. Okay, because it is going towards the direction of gravitation. Now most of you will do the sign mistakes here. Some of the problems you have to take plus g, or some of the problems you have to take it as minus g. So be careful. So look at this, the apple is falling down. So velocity is equal to v naught plus gt. Now why this g has come here? Because here the kinematic equation is v is equal to v naught plus at. A here I am going to take it as g. G is nothing but the gravitation constant. Okay, so h is equal to v naught t plus half gt square, and this is the third equation, correct? V square minus v naught square is equal to 2gh. So wherever you have a, you are going to take it as plus g, because the apple is falling down and it is coming towards the gravitation force. Okay, next. So these are the four important equations, and I'm going to solve problems on it. Now let us try to understand. When a body is dropped freely, then initial velocity is 0, a is g, and the displacement is h. So velocity is directly proportional to t, and h is directly proportional to the square of the time taken. So you can take this time formula, you can take down in your notebook. T is equal to root of 2h by g. So most of the time in exam they will ask you what is the time taken if a body is thrown from certain height. They will give you the height, you have to know the value of g, and you have to tell the answers. Next, v square is equal to 2gh. Okay, the second equation, v square is equal to, because the initial velocity is 0, correct? So v is equal to root of 2gh. So h is equal to g by 2 into 2n minus 1. Okay, so these are the things, these formulas you have to keep in mind to solve the problems. And the last data here, acceleration due to is in vacuum. This is very important. I'll show you one experiment. In previous class I have shown this experiment to the class, but right now just remember and write down this line here. Acceleration due to gravity is same for all bodies in vacuum. All bodies in vacuum. Okay, fine. I hope you have taken it down. Next. So all the above results are true for body falling freely under gravity, and also true for a body starting from rest and moving with uniform acceleration. So this, all the results which formulas which you have written, this will be applicable for these cases. Body falling freely under the gravity, body starting from rest and moving with a uniform acceleration. Now next, the acceleration of a body in medium is g dash. Okay, so this is given as g into bracket 1 minus the distance of the moving and the body here. This takes into account only buoyancy force. Okay, now if the body is moving in, t of the object plays an important role here. Next, when a body of density rho b is immersed in a liquid of density rho l, the resultant downward force of the body is equal to the gravitation force. Just write down an equation. Just take down this equation. Okay, don't write the definition, just take down the equation here. The mass of the body into g dash formula you have taken in the last slide. So the mass of the body into the gravitation minus the mass of the liquid into the g value. Okay, so this is how you are going to use. So take down the last value here. The mass is nothing but the velocity constant into the density. Okay, so when a body is immersed in liquid, in water or in oil or in milk or anything, so this formula is going to be used. Next, where V is volume of the body, a body falls freely from a height h on to a sandy surface, then it penetrates a depth y. So what happens? Sometimes a body falls and makes an um, it makes an impact on the ground. It makes a hole. So what is that penetration? How much depth it has gone? So for that purpose, I'm going to use a formula that is retardation formula. Okay, so this is the formula. Take it down. So these are the formulas that you have to remember. So retardation formula and the time taken, these are all important to solve your problems. Next, water drops fall from a tap of height h at regular intervals. If the first drop touches the ground at instant, the nth drop detaches from the tap, then so this kind of questions on the water drops can be solved by these formulas. Okay, so the time taken is root of 2h by g, and the time interval between two drops is t by n minus 1. So n is nothing but the number of drops. Okay, then nth drop means 50th drop or the 100th drop. So now ratio of separation between nth and n minus 1th drop, here this is constant. Okay, next. A freely falling body passes through 2 points A and B in time interval of t1 and t2 from the start. Then the distance between the 2 points A and B is, so write down this form, so g by 2 into bracket t2 square minus t1 square. This is the formula for using if a body falls B in a time interval t1 and t2. Next, a freely falling body passes through point A and B at distance h1 and h2 from the start. Then the time taken by it to move from A to B is, this is the formula. Just take down the formula, time taken if a body is moving from A to B. That's it. And a distance height is given here, h1 and h2. Fine. Rest displacement and all, I'll tell you. We have some other formulas also. I'll give you that easier formula. Now try to answer some questions. Among the following, which moves in the uniform non-uniform velocity? Light in a homogeneous medium, sound in a homogeneous medium. Next, you have a body and you have all the above. The answer is a free falling body. The displacement in the nth second of time is given by the equation. Yes, the displacement in the nth second. So what is the answer? Option D. Next. So here we have today completed a body falling from space to the earth. So I am taking G as positive, acceleration as positive G. Tomorrow's class will be watching acceleration will be negative G. Okay, so look at this. The apple, now I'm going to throw it up. Okay, now the apple, I'm going to throw it up, and now I'll be taking acceleration as negative G. Understood? So now these are the two cases. When something is falling down, when some object is falling down, I'll take acceleration as positive G plus G, and if something is going up, the work is going to do against the gravitation, so I will take acceleration as minus G. So in tomorrow's class, we'll continue with this and few more interesting problems. So come prepared with the basics.